And welcome everybody to this discussion today. Excited to kick this off and getting into talking about some best practices around launching an IoT solution and what you need to be thinking about to enable a quick and successful launch. And before we dive into that, I do just want to take a quick second for those of you who don't know who Aris is, just kind of explain why we are here and why I am here talking about this today. So we are an IoT solutions provider, and we kind of have two sides of our business. First and foremost is providing cellular connectivity in an intelligent IoT-focused cellular network to solutions that need cellular connectivity, wherein we provide both the network access as well as connectivity management and additional connectivity features to help optimize a network for what IoT devices need as opposed to consumer handsets. Obviously, a lot of what we're going to be talking about today falls in line with the connectivity aspects of it, and some of the key challenges around how to leverage connectivity to enable a rapid solution launch and a successful solution launch. We do have another side of the house, which is our mobility platform, focused on providing close to end-to-end, basically application solutions for the Internet of Moving Things. Whether that be connected vehicles or other connected assets that are moving around. But again, today focus more on what we do on the connectivity side. And so without further ado, let's go ahead and jump into what we're going to be talking about today, which is really around how to launch an IoT solution fast and what are the key things that you need to be thinking about. Some best practices for getting a solution out the door, getting a connected solution out the door. Quickly is obviously the key with getting launched, but that also comes with some potential challenges in terms of finding the right balance between developing all features and testing and getting them out the door versus getting something out the door fast and then evolving. And so if you take the second approach, what are some of the key cost and efficiency challenges that you are going to encounter as you try to get this solution out quickly and as you look to evolve it over time? Then last, what we're going to do is take a look at some of the solutions that we have been working on to help customers manage the challenges of a connected solution and how to enable getting that out the door quickly and what some things we have for you that can help you get something out the door quickly and make it more cost efficient and better performing for you down the road. Okay. So when we look at launching an IoT, so connected IoT solution, you obviously want to get it out the door quickly and you want to make it successful. And so what we're going to talk about now is a couple of the things to think about that are going to help you launch an MVP quickly. And I use the MVP definition there, minimum viable product. The concept there is a solution that you can get out the door that will enable you to gain initial traction in the marketplace, but it may not be the perfect solution down the road. And so how can you balance launching that minimum viable product quickly while enabling you to develop your solution and to expand the value of your solution without having to replace those initial devices? And that really gets into then the second bubble there, which is to enable over-the-air device updates. What we're talking about there is the ability to send down a configuration change of a software update to the device, add new features, fix security patches, things like that enable you to dynamically change the way these devices are going to behave and do so over time without having to recall those devices physically, because ultimately that allows you to have an environment where you can update and change on the fly. As you learn about things that need to be fixed, as you want to introduce new features, as you see things that need to be fixed, you have an environment where you can actually execute those changes to the devices out the door without having to bring those devices back in for a physical hands-on change and update. This is one of the key, avoiding those physical hands-on updates and the recalls is one of the key trends we see when we look at the difference between successful or unsuccessful IoT deployments. And we've helped guide hundreds of companies through their initial set of launches, and those that have been able to build this type of environment to create a more flexible solution, a more dynamic solution delivery environment, are the ones that we typically see are able to get past the hump of the first few thousand units and then grow to scale because they can change as they learn and as they grow. And so what I'm going to do now is walk you through a couple use cases where this capability has been very, very critical in a couple different use cases that ultimately enable different drivers for this type of capability of updating devices. And so the first one that we're going to look at was a company, actually a large, successful existing tech company that needed to launch a new solution to market quickly. They were building a solution. They had some great ideas around basically an industry where there was already a lot of competition in this space. Specifically, this was around asset tracking and cold chain monitoring, tracking basically trailers that need to be refrigerated and whatnot as they move around the world delivering goods. In this case, perishable goods. And so this is obviously a marketplace that has existed for a while. There are lots of solution providers that have been very successful selling into this marketplace, and this company was able to come up with a pretty smart way around their hardware that enabled it to be very cost effective. Obviously, with this industry specifically, the cost of hardware is one of the big drivers, one of the big areas where companies look to provide differentiation against their competition, and in a lot of ways, it's a race to get that hardware BOM down to zero, the BOM cost. So they were able to come up with a kind of a special way to make a low cost device hardware, and that's really where a lot of their focus was in terms of building their solution, building their differentiators. And the application and the feature reporting side of it was kind of secondary in terms of where their focus was. And so what they knew they needed to do is they needed to get a pilot program out the door. They felt good about their hardware. They needed to test it, but they needed some real world examples and some real live experience to fine tune how these things were going to communicate on the application side. Did they need to report every 5 minutes or every 15 minutes? And what was the right combination of connectivity features and capabilities that delivered the most value to their customers? Those were things that they were never going to be able to do inside their own testing environments. They had to get devices out in the real world to see how it was going to go. This company was wise enough to know that they weren't going to get it right. It wasn't realistic to expect to get it right the first time. And they knew that they were going to encounter bugs. They knew that they were going to need to make changes. And they didn't have time to create a structure where they'd send these devices out with a certain set of capabilities and then bring them back in, make changes, and then send them back out and then bring them back in and so forth until they got it right. What they needed was an environment where they could get devices out the door, they could test them, they could play around with new features, play around with new configurations, and see which ones were working, which ones weren't, which needed to be fine-tuned. They needed a way to fix those issues, those bugs as they came up, because they knew that they were going to come up, and sure enough that they did. And so for this customer specifically, for the first few months of this pilot program, they were sending down multiple updates down to these devices on a daily basis. And they, having that environment where they could change and update and navigate the lessons learned and implement the lessons learned was very critical to ultimately their successful launch. And the result of this program was that they were able to lock down the specific features, the specific capabilities that they needed to. They got the right lessons learned, and they got the experience they needed to kind of perfect this initial solution, and it allowed them to win a rather sizable initial customer, which really helped them gain traction, and grow. And as we know, with launching a solution, getting the first set of sales success is very, very important. And so fine-tuning what was going to stick with those customers with this very dynamic pilot program enabled them to lock down the value and deliver to that initial customer, which they then leverage that momentum to continue to grow and to continue to expand their solution. So again, kind of an example of how this dynamic service delivery environment and this ability to update devices on the fly was a critical component to the success of their initial launch. The second use case we're going to look at was actually an auto manufacturer that was a little behind schedule in terms of deploying a connected solution into the marketplace. Many other car manufacturers had beat them to their a robust connected car solution, and so they were in slightly different of a position where they kind of knew exactly what they needed their program to look like and what features were important to customers and so forth, but they were already late and they did not have time to go especially in an industry that traditionally moves pretty slow, they didn't have time to fine-tune everything and get everything perfect and get every feature that they wanted built in and tested and proven before they started getting this aftermarket or retrofit solution into the marketplace. They had to move quickly, again, because they were already late. And speed was very, very important to get this thing, at least an initial MVP, going. And so what they did for this retrofit solution, which was a plug-in device that went into the vehicle that enabled some of the key connected car functionality that we've become accustomed to, things like remote door unlock, for example, or climate control and so forth. They needed the ability to get the MVP out as quick as possible. Again, it was a race against the clock since they were already behind their competition. And so getting the MVP out with the key set of features and functionality, and then being able to update those devices with the additional capabilities that they already knew that they wanted. For them, it wasn't as much about learning because they already knew what they wanted it to look like. That blueprint had already been established a little bit, but they didn't have the time to wait to develop all of those features before launching. They had to get an initial set of capabilities out the door into their solution, into their vehicles that were out there, and then build on that over time as they were able to then build out the remaining set of features, send those features down to devices remotely without having to, if they had built a structure where the vehicles needed to be recalled back to the dealership to be physically updated and so forth, that never would have worked. And so they needed the ability to send down these updates over the air remotely, and so that these devices that were installed in the vehicles could have additional features layered on top of them to add more and more value as they went. And so, while the first example we looked at was really around, getting an MVP out the door so that you can learn and figure out what works best and make those changes. This is an example of when you know what you need to do, but you don't have time to do all of it. Getting that solution out the door, gaining initial traction, gaining some momentum, and then updating those additional layers of features and the additional sets of capabilities after the fact is another way of how this, remote update capabilities made the difference in terms of making their solution successful or not. And had they not enabled this kind of environment to be able to update these devices, they wouldn't have been able to get this MVP out the door and then add the necessary capabilities on top of it. They would have had to either launch with a static set of capabilities that wasn't good enough, or they would have had to make the decision to wait until they had all of the capabilities. And again, they did not have time to do that. So having this dynamic feature delivery environment really made the difference in terms of allowing them to get what they needed, which was a quick launch and then ultimately build towards the feature set that they needed. Then the last use case we're going to look at is kind of more of a hypothetical use case that's going to become very, very real. And so one of the things that we're seeing, and for those of you who have been reading into some of the new regulations around IoT and especially around connected devices coming out, there is an increase in government regulation into the IoT space, largely around security and largely in response to some of the famous security breaches that have happened over the last few years. Most of you, I'm sure, were familiar with the Mirai botnet attack, where basically internet-connected cameras, wireless cameras, were hacked and then turned into a weapon that were programmed to attack some of the largest websites and ended up bringing them down for a period of time. All because the devices were not secure. They were accessible from the open internet. And someone found a way to get to these devices and use them as a weapon. And so one of the examples of one of these laws coming out is a bill that's getting passed in the state of California right now. Chose this one because that's where our company's headquartered, but many states around the U.S. are starting to move near identical regulation through, and we're starting to see it in other countries as well. In Europe, we're seeing very similar traction, very similar trends like this one. But basically, this law, SB 327, it places a heavy importance on making sure that devices are secure. And one of the best ways to, the other thing that it'll start to do is enforce that companies need to be able to fix security issues if they are discovered. One of the ways to become compliant with that aspect of this law is to enable a remote update environment where you can send down a security patch to a device if a security breach is discovered. And now one of the things you may be thinking is, well, we're already figuring out our own set of device security aspects, and so we think we've got that captured. But if you ever did discover, if something came up that you didn't have a solution for, if you don't have the ability to send down an update to that device, you're going to have to recall that device. In the example of the Mirai botnet that I brought up, the camera manufacturer that had those unsecured devices out there did not have a way to remotely update those devices. They had to recall them. The company went out of business, and so there are severe impacts to your business. If you don't think about how to navigate some of these new regulations coming up, and we've seen in related other cases, the government is willing to enforce some strict penalties. A lot of actually, what's going on in Europe with GDPR. There have actually been a couple cases of financial penalties for not following these regulations. So that precedent has already been set, and something that we may see, the government entities move towards, in the IoT space here very, very shortly. Could have a very, very severe impact on companies looking to deploy a connected solution. But again, one of the resolutions, one of the ways around some of these regulations, or to be compliant with some of these regulations, is to enable a remote update environment so that if security breaches are discovered, you can send down updates to fix those, to patch up those security holes, to make it so that your devices do not need to be recalled. So when we look at launching fast and successfully, again, one of the things that we see, you have multiple objectives that you're trying to achieve as you go, right? Getting something out the door quickly and being able to learn and update and grow from there. Being able to create that dynamic feature and service delivery environment so that you can make those changes to increase the value, increase your chances of having ultimately a successful deployment, and being able to update those changes as you go. The kind of key summary here is that, and hopefully what those three examples I went through, started to shed light on, is that ultimately every IoT solution is going to need the ability to send down these remote updates. Not only will it help you launch a solution faster, it'll help you grow that solution, expand the value, and it'll help prevent disastrous security breaches, or at least the impacts of those security breaches down the road. And so one of the key recommendations that we provide to customers and companies that are figuring out, what they need to do to launch a successful solution and how they need to go about it, is to start with the OTA framework. Make that one of the key things, the first things that you go figure out, so that you can create that environment, so that you can learn and update, that you can add features once you come up with them, or once you're able to develop them, and then resolve potential very harmful issues to your business by being able to send down those updates and those patches. So creating that framework is very, very important, and hopefully those last use cases kind of showcased a little bit of what that framework can do for you. So what we're going to do next is jump into some of the key challenges around building and executing on this framework. So if we start looking at key cost and efficiency challenges with managing a remote update environment, the first one is around costs. Obviously, costs are always very, very important, and especially when looking at when updates can go wrong, cost is one of the bigger impacts that it can have to a business. And so there's a couple different aspects of the cost here. The kind of obvious, or the most apparent in a lot of people's minds, is the updates are going to increase the amount of data that you're sending and receiving with these devices, and so that's going to increase the network activity, and then therefore increase the cellular network costs in this case specifically. So with the increased usage and the increased cost, getting it right the first time is paramount, because it's relatively easy to manage the expectation of, if I send this update down to this device, I expect it to increase by 3 megabytes, and I can plan around that. But the problem where the additional cost can spiral is when it doesn't go through successfully, and you have to retry, and you have to retry, and you have to retry. And that's when it starts to become an unknown cost. How many times do I need to retry before I get it right, before it goes through successfully? That's where the cost can start to become a concern. It's around the unknown. And third is when you start to look at the operational cost of managing these processes. So many companies resort to a manual process, tracking the amount of devices they have, say, in spreadsheets, and sending down updates, and then looking to see which devices were successful, which devices weren't. A lot of people, a lot of costs spent in the manual operations of these updates and executing these updates. And as we see here with this first example, that can cause quite a bit of pain from a cost perspective. One company we worked with was in the fleet management space, and they needed to send out a relatively large update down to their devices that was north of 40 megabytes per update. So, again, working with us, they were able to kind of plan out what they expected it to be from a cost perspective, and we gave them a special set of rates for this update that were more efficient and more effective at 40 megabytes, which was much higher than their typical usage profile. But they had to send it down to quite a few devices. Over 100,000 was their entire fleet. The real issue that they had was over the course of the previous couple of years, they had deployed a couple different types of devices. Some of them were working on one operating system, a couple of them were working, and some of them were working on a different operating system. So what that meant is that they had to send down the right 40 megabyte upload down to the right devices. They had operating system 1, that update had to go down to those devices, and the update for operating system 2 had to go down to those devices. And if you sent down the incorrect update, the device would not know what to do with it, and it would just be a wasted 40 megabyte transaction on the cellular network. And because they were using a manual process of tracking the devices, identifying the devices, and then tracking the results, manual, as we all know, introduces the element of human error. And sure enough, that happened in a very big way here, where for a significant portion of those devices, the wrong updates were sent down. And so that was, again, a wasted transaction on the network because the file was downloaded, but the device couldn't do anything with it. And so they had to, track that the wrong file went down to the wrong device and then correct it and send down the right file. And so that was a second attempt to send down this rather large file. And so it was really because of the manual operations that they had some pretty significant and unexpected costs. Again, if all updates went down to the correct devices and worked the first time, that was a cost that they had planned around and they were expecting. In this case, with a significant chunk of devices that were forced to retry and re-download, that introduced a whole new set of costs that they were not expecting, and that's where it became a challenge. Again, due to the fact that they were using manual processes, which introduced the element of human error, which, as we all know, anytime that element is present, it will show up and it will cause problems. And so not having an automated solution in place, not having software in place that could make sure that the right updates went down to the right devices, ultimately led to a very, very, very costly update campaign, and something that obviously they were not expecting and were not too pleased about. But again, due to the fact that they relied very heavily on manual operations, which cause a higher degree or higher likelihood of human error and therefore costly mistakes. And so we're going to circle back to this, but for this use case, keep in mind that it was the manual operations that caused the problem, and what they really needed was the ability to automate at the software level to reduce the risk of human error. The next challenge with these updates is really around the time to complete. A large reason that it takes a long time to complete, campaigns, and when I say campaign, I'm really meaning, sending down the update to all of the devices that need to receive that update and treating that as a separate program, a separate campaign. The time to complete any one campaign can be pretty significant, especially if you're relying on blind update attempts. And what I mean by blind updates is meaning you are not considering what is that device doing on the network right now, on the cellular network. Is it connected? Is it not connected? Has it connected recently? Has it been powered off? If a device is in a deep sleep state, if, let's say it's an LTE-M device that can only receive or send transmission, it can't do both. Maybe it's sending information and therefore can't receive the update. Maybe the device is powered off, and so even with an SMS attempt to get it to wake up, it's not going to come back online and be ready for an update. If you start trying to send down updates to those devices, you don't have to worry as much about the cost of sending down that update because it won't go through because the device is not online, but it will take a much, much longer time to execute that campaign and ultimately get that device updated, because you then have to start manually tracking which ones went through, which ones didn't go through. And this can happen with both large-scale deployments and a small set of deployments. If you don't know what devices are doing out there in the field, if they're connected, if they're not, it can cause big problems for you. And one example of that is a device manufacturer in the healthcare space. They needed to send down an update to their entire set of devices, which was over 500,000 total units. And so basically they decided to target 10,000 devices at a time, and they would execute this campaign in batches of 10,000. And so they would select 10,000 and send down the update and manually track which ones were successful and which ones weren't. And if half of those went through on the first time, then they'd take the ones that didn't go through and add 5 more thousand and do another batch of 10,000. And they'd have to manually track the results, and on and on and on and on it went until it took over 6 months to complete the entire update process for them. Largely because they did not have visibility into what devices were doing on the network. They did not have any sort of automation or automated software that could help schedule and automate the retries to those devices. And they didn't have a way to be notified when devices were ready to receive an update. And so they just had to, again, blindly attempt these updates over and over again, which combined with the manual and slow processes because of the manual aspects, it took a very, very long time to ultimately complete this update. And so, adding to the operational cost element as well, sure, but especially in the context of security updates, which in many cases may need an immediate impact. They may need to be sent down immediately. They may need to go in effect immediately to ensure that the devices get back online and are protected. And so, not knowing when devices are online or when to send the update can cause big problems. Now, one other concept I want to introduce really quickly is what happens to being able to send down updates as we move towards LTE-M and eventually NB-IoT. Now, obviously, these aren't the only cellular networks for IoT devices. Many deployments are still going to use or move to LTE, higher bandwidth required devices and so forth. But especially with the move to LTE-M, and for those of you thinking about LTE-M and ultimately NB-IoT, there's one thing I want to introduce that is should be a very big consideration for you around this topic of managing updates down to devices, and that's really around how these new technologies introduce new network congestion that's going to be very difficult to manage around. So for those of you that have looked into LTE-M, you know that these are lower bandwidth technologies that are geared more specifically to IoT devices that have traditionally lower usage profiles. Sensors and monitors as opposed to, devices that are streaming video, for example. One of the key benefits is much lower module costs and much better battery life. And so very attractive to two applications that kind of fall into that category. But because these networks are low bandwidth, that will cause additional network congestion concerns. And so, the way to look at it is not that devices are going to have a hard time on towers or getting information out because of the relatively low usage and low packet size nature of these devices and sensors. They should have no problem sending information out. The problem becomes when you have to send information down to the devices in the form of a remote update in this context. That's when it's going to become a big challenge for a couple reasons. The first is that the initial implementation of LTE networks is they're half duplex devices, meaning the impact of that is that devices can either only send information or only update information. They cannot do both simultaneously like they can in, for example, an LTE device. The second thing that's going to impact network congestion is the capacity for information going down to devices at any given cell site. at a very high level, cell sites are restricted generally to about 250 kilobits per second in terms of throughput speed. That's for the entire cell site for the LTE-M channel. Now, depending on how many devices are connecting to that tower at any time, that's going to be divvied up even further to those devices. And what we're seeing is that on average, any given LTE-M tower can only facilitate anywhere between 25 to 50 simultaneous download transactions at any given time. Imagine a scenario where a bunch of parking sensors are all in a downtown area, as well as waste bin sensors and light sensors and other sensors that are all on an LTE-M network. If those are all talking to the same cell tower, there's likely going to be many more than 25 to 50. And if any chunk of them are trying to do any sort of update at the same time, that's going to cause a big problem. And really slow down, make the challenges even worse in terms of completing the updates and getting them done in a reasonable time frame. So I just wanted to cover that as largely an aside, but just to paint the picture that if you are considering moving to LTE-M or NB-IoT, the challenges of managing updates are going to be even more difficult. So there are a couple options to look at, and we're going to cover two real quick before we jump into a third, which is how we are going about solving this problem. And the first is to create homegrown processes and tools. Benefit here is that you can get them customized to your needs and how you need things done. But they can come with a high development cost and may rely too heavily on things that you initially think are okay to do manually, but that can change over time. And so, difficult to get up and running, not something that we see a lot of people try to do initially, and something that can carry a heavy price tag up front. The second is then to look for tools and capabilities from other third-party providers, whether it be extensions of hardware you're using or other software providers that can come in. The nice thing is they're off the shelf, they're easy to use, relatively less expensive than kind of creating your own set of processes, but they may not be fully customized to what you need. And they may not have visibility into the network, and they may not be able to tell you, for example, if there's going to be congestion issues for that device, given everything that else is going on, and is it connected, is it not connected, all of that. The connectivity awareness can still be a very important capability that some of those third-party tools do not address. So, and that is how Aeris is thinking about and working to solve some of these update challenges. And really, it's with our Smart OTA campaign management platform, which ties in connectivity awareness to help automate this whole process. So basically what we've done is we've created a set of software capabilities that not only help manage a campaign in terms of selecting devices that need an update, giving you the ability to upload whatever file, whatever update, whether it's a bug fix, a new feature, or security fix, update that into the platform, and then take care and then automate the scheduling and delivery of that file down to your devices. The key difference with the way that we're going about it is that we are leveraging the device connectivity and the network connectivity status to know which devices are ready for that update. So when we look at the example of especially with the LTE-M network congestion, knowing which devices are ready to receive the update, which ones leveraging cell tower location information, for example, to know which devices are at congested cell tower sites, which ones are in the kind of, quote, ready state, depending on how your application and your device behavior is, which ones are ready to receive that update, and prioritizing sending those updates first. So we increase the success rate of sending those updates down to those network-ready devices, and then automate the tracking of which devices have been sent the update, which ones were successful, which ones have not received that update yet, and then helping manage to identify when those other devices come back online and then are ready to receive the update. So our whole goal is to help reduce the cost and reduce the pain of managing these updates, get them executed, get the campaign executed ultimately faster because you're minimizing the amount of manual operations, and do it in a far more efficient way because you're maximizing the chances of success by targeting those update-ready devices first. Then, before we get to your Q&A, just to recap, a lot of what we talked about was, the ability to what you should be thinking about as you look to launch a solution quickly. Get the MVP out the door. Leverage our OTA management capabilities to help you create that dynamic service delivery environment where you can update features on the fly. As you learn, as you want to introduce new features, or as you discover things that really need to be fixed, and leveraging that connectivity awareness to help make that part of your life much, much easier and much less costly. And by improving that efficiency and controlling those costs, ultimately you're going to result in a better operational structure for your devices going forward, which is also going to help you scale past the hump of the first couple thousand devices and beyond, as you keep these capabilities with you, so that you can continue to enable that dynamic service environment and update features on the fly. So with that, I'm going to first thank you guys for staying through and listening. Hopefully what we went through today was interesting. Please reach out to Eris if you have any questions on anything I went through.